Colin, we'll just give it another minute, okay? Okay, good afternoon, good morning, everyone. Thank you for joining us for today's presentation entitled Introduction to the Premier Software Suite for Modeling All Types of Water Environments. We do expect the webinar to run just shy of 1 hour today. I would like to kindly remind everyone to please remain muted with your video turned off during the presentation. Any questions you have during the presentation, please feel free to use the chat function at the bottom of your screen, and we will address them all at the end of the presentation. For future reference, we will be recording today's webinar, and you will receive a link once it is available on our YouTube channel. For today's presentation, I would like to introduce Mr. Colin Roberts. Colin is the Director of Mike Powered by DHI, based in the US, and he helps our customers determine what technology they need to solve their water challenges. Prior to relocating to the US, Colin was the Managing Director for DHI New Zealand. And with that, Colin, I now hand it over to you.
Yeah, thank you, Barbara. And hello, everybody. Welcome to the webinar. Just to check, can you hear me okay, Barbara?
Yeah, I can hear you fine.
Okay, great. And you can see the PowerPoint?
Yep.
Super cool. Okay, let's jump straight in. Some of you may be familiar with DHI and the Mike software suite, but for those of you who are not, I'll just give a quick overview of DHI, quick intro to DHI, and then we'll jump straight into the Mike software suite. I'm not going to go into a lot of detail on specific software products. I'll give an overview of the concept of the Mike suite and highlight the particular products in there. And then I'll move on to talk about some viewers that you can access and APIs to get access to Mike software and Mike technology. And then we'll dive in to have a look at the licensing and different ways you can get access to the Mike software. Briefly, then I'll mention about the support maintenance agreements that we have, and a quick mention on training, and finish up with a look at where we're going with Mike and with DHI technology into the cloud. I think if you've got questions as we go, as Barbara mentioned, just feel free to post them and we can pick them up at the end of the presentation. Okay, so DHI, in short, we're an interesting organization. We are about 1,200 employees, 1,100 to 1,200 employees located around the world in 30 plus countries. And we've been in existence since the 1960s. And we are, what makes us particularly interesting is that we're an independent and private self-governed organization. So we have no external shareholders that we are producing a profit for. So we're self-driven in terms of the strategic direction that we set, and the profits that we make from our services and technology are reinvested back into developing those services and offerings more and more. Our knowledge, the people that work at DHI are an interesting combination of domain technical experts. So that's, hydrology, hydraulics, coastal engineering, urban infrastructure engineering, and technology developers. So software developers, data scientists. And it's that combination that we feel allows us to create software technology that really allows you to address the real world challenges that you're facing out there. The fact that we're around the world in 30 offices allows us to make this knowledge globally accessible. So our technical support for the software, we have practicing engineers and scientists who use the tools themselves, so they can provide you very hands-on and relevant support. One thing I just want to highlight is that it's this combination of leading domain knowledge and technology expertise that allow us to create this mic software. But it really doesn't stop with off-the-shelf software products. So if you find yourself needing some bespoke software utility or tool or platform, then we're very comfortable and happy to talk to you and co-create some solutions to fit your needs. I just want to highlight here the evolution of our technology. Started off, as I said, in the 1960s, actually making physical hardware to create waves in laboratory wave basins, three-dimensional wave makers. And then in the 1970s, started working in computational hydraulics, developing the computational kernels, the engines, particularly for coastal and urban and water resources domains. And this computational code was used in-house until our end clients and the consulting industry started requesting access to this code to be able to carry out the analysis themselves. And that was really the dawn of the mic simulation software era. So in the 80s, the code was professionalized and GUIs were developed so that it could be made available to the industries that it would serve. So the mic simulation software that we'll look at has been, on the market since the 80s and continually developed since then. And in the meantime, since that was released, within DHI, we were then focusing, as well as maintaining and developing the mic simulation software we were working on decision support systems. And that culminated, again, similar pattern in a commercial release of our decision support platform that we call Mic Operations in the 2000s. And I'll talk a little bit about that platform and how that could help you out, what you could potentially do with that. And so we've got the mic simulation software technology, we've got Mic Operations software platform, both out in the marketplace being maintained and developed. And since then, we have been working on trying to bring data science methodologies and techniques that's really been made more available through the cloud infrastructure and cloud computing paradigm that's emerged. And so in the last couple of years, we've developed a strategy for having our technology in the cloud, and that's our Cloud Bridge strategy. So at the end, I'll just mention a little bit about that briefly. It's not just putting our mic desktop products on a computer, on a platform in the cloud. It's a whole paradigm shift, and potentially with or without mic, it's an interesting time and a potential major change for how we use modeling to solve problems. So the mic software suite, The main concept, main message I want to get across here is that it's not just a piece of modeling software to calculate, say, flows in a harbor or flows through a sewer pipe. It's actually a platform that you're investing in when you get into the Mike software suite. So this is an example for coastal flooding. And if you start at the bottom layer there with data analysis, so we have some data portals and various databases that you can access and pick up your data from. Of course, you can carry out data analysis on that data, but a lot of that data will form the backbone to the layer above, which is building models. So these are deterministic computational models, and that's traditionally what people think of as Mike, but it's just one layer in this multi-layered approach platform. And of course, once you've invested in setting up a simulation model, you can do way more with that model than just design analysis or planning assessments. You can take that model to the next level, the next layer, and actually carry out forecasting with that model in a real-time system. And that's where the Mike operations decision support platform comes in. It allows you to take that model that you built that was using the data that you got and operationalize it. And it doesn't stop there. Once you have a real-time system that's making forecasts about the system that you're interested in, you can take it to the next level, and this is where we see the cloud technology really coming into the game here. You can actually start to prescribe and control your system. If that's urban infrastructure, offshore assets, water resource infrastructure, you can have your deterministic model, you can have your forecast model, and that can be augmented by linear models, and AI neural network models that you can literally run hundreds of thousands of simulations very, very efficiently. And they're schematized from the deterministic model. And that allows you to test out scenarios and investigate the most optimal way to configure a system. And we're not talking about, looking 7 days ahead and saying how it should be set up. This is kind of near real-time prescriptive control. So that's something you're going to see a lot more coming out of DHI and coming out of Mike, this prescriptive control, model predictive control, MPC as it's known. And all the time as you're moving up these layers, you're really enhancing the amount of, or creating actionable information and realizing the investment that you've made further down those layers in your modeling. It's not to say that you have to only use the Mike system, of course. So if you're, for example, if you're setting up a model, you can, of course, bring in data from other sources. Just as if you're having a forecast system established, you can use the Mike operations system, but you could also use other systems that are calling the Mike engines, the Mike simulation engines. And I'll talk a little bit about that further down the presentation here. So it's very exciting if you're getting into Mike technology, that it's a whole platform. It's not just a piece of software that does one particular thing. So just having a look at that stuff at the on the lower layer, the data, and here's 3 of our digital data portals. This is something we're going to be continually releasing and expanding as we add more data sources in here. But 3 I just want to highlight to give you a flavor for this. And at the end of the or after the presentation, I'll leave my the Mike email address up. And if you're interested in getting links, I've prepared links for all of the things that I'm showing here. So if you make contact with us, then I can make sure you get a list of the links for these things that interest you. So we have the bathymetry data portal, and basically that allows you to log into a portal, and you can search globally for information for coastal waters, for bathymetry information, and you can search and download data that is in the directly in the MIC format, ready to go. The data is ranging from resolution of 2 meters to 90 meters. And you can just hone in on your project area and only pay for the data that's contained within your project area. And the bathymetry data sources are continually being added to and updated. So if you're a coastal or marine professional, then that could definitely be something to check out. The MedOcean data portal is a pretty powerful portal. You can basically get access to nearly 40 years of global MedOcean data and carry out validation reports and some typical analytics that you might want to do on that MedOcean data, calculations within the portal. And the data, again, can be extracted from high resolution, local areas, right through to regional coverage and even global coverage. So when you log into the portal, you get instant access to this data, and you can purchase it right there in the online shop. And then the boundary condition generator. So if you're a MIC 3, so that's our 3-dimensional hydrodynamic modeler, you'll know that, or if you're a 3D modeler, you'll know that setting up the boundary conditions for these models can be quite challenging and time-consuming. It can take the order of days, if not weeks, to get boundary conditions set up and stable for 3-dimensional models. So this boundary condition generator is pretty cool in that once you have a model mesh of the domain, you can load the mesh into the generator and rapidly set up boundary conditions that are robust for water levels, currents, temperature, and salinity data. So you can dramatically reduce the amount of time you're spending defining your boundary conditions. Especially if you change your model domain, you don't have to then invest all that time reestablishing and stabilizing the boundaries. You just bring the mesh into this boundary condition generator, and away you go. If you have a support and maintenance agreement, then the boundary condition generator is free access. So just jumping onto the MIC software for simulation. So this is our software circle. This represents the majority of our desktop water simulation software. And as you can see, it truly models the world of water. We have a software tool for pretty much every aspect of the water simulation that you might want to look at. So I'll just go around the circle, starting with the MIC 21 and the MIC 3 on the left there. So this is MIC 21 is our 2-dimensional model, depth averaged, and MIC 3 is our 3-dimensional model. It's a layered model that has flow exchange between the vertical layers. And we've just actually released update number 1 to our 2019 software. And that has, in the release for MIC 3, we actually have a full non-hydrostatic 3D solver now within MIC 3 that comes as part of the MIC 3 software. So if you have MIC 3 or you're thinking about 3D modeling, you can do 3D layered modeling, or you can go into more depth and actually, or more detail and get non-hydrostatic simulation, basically solution of the Navier-Stokes equations. So those two, MIC 21 and MIC 3, are the backbone of our coastal and offshore model simulation software. All of this software around the circle is again layered in that you can build complexity on top of the basics. So the basics are, of course, the hydrology and hydraulics, or hydrodynamics, the flow and where the flow goes, water depths. But then on top of that, within each software product, you can add on processes such as advection dispersion, transport processes such as cohesive and non-cohesive particle transport. You can actually have the models do morphological simulations, so they're actually updating the bed or the boundaries during the simulations. You can add on water quality processes with our Ecolab platform. In the middle there, you'll see Ecolab. And Ecolab is basically an open equation, differential equation solver that accesses the Mike simulation engines at runtime. So if you have a process that involves parameters that are calculated by the Mike software and also parameters that are outside of the Mike software, then you can code up those differential equations in Ecolab, and as the simulation progresses, it will carry out those computations. So traditionally, Ecolab's been used for the hydroecological aspects, so nutrient cycles, water quality processes, simulation of ecosystems. And more excitingly, it can be extended so that it can actually represent agent species within water bodies, such as fish, marine mammals. And so those agents, you can program in the behavior of those agents, and they will actually respond to the changing environment that's predicted in the simulation model. And so that's the marine hydrodynamics and the layering on top. We then have LitPack, which is our coastal process simulation software. And that can be used for very localized reaches of coastline, right through to whole shoreline management cells and whole coastlines. And this typically is used to look at the kinetics of coastline processes and evolution over time, long-term evolution of shoreline profiles. Moving underground, we have our FeeFlow software at the top there, which is a 2D and 3D finite element groundwater simulation software. And again, the same thing, you can calculate the flow, and then on top of that, you can simulate mass and heat transport within the groundwater systems. It's a very capable, very powerful groundwater simulation platform, and has a full, you can do 2D and 3D meshes and full 3D unstructured meshing within the FeeFlow software. These softwares are self-contained in the if you need to generate meshes, boundaries, that can all be done within the software platform. Then straddling groundwater and surface water, we have our Mike Shi software. And Mike Shi basically is a simulation tool that looks at the whole hydrological cycle. So right through from precipitation, snow storage and snow melt, overland flow, channel flow, the unsaturated zone and the saturated zone. So within Mike Shi, there is a overland flow solver, river channel solver, and unsaturated flow, and a groundwater 3D finite difference groundwater solver. And these domains are dynamically coupled internally within the software. So you're internalizing the boundary conditions, say from the surface to the unsaturated zone, that's to the saturated zone, that's internalized. So you don't have to do a simulation and transfer boundaries to your groundwater model. You can simulate the processes in one go. And again, Ecolab sits on top of Mike Shi, so you can simulate the environmental aspects of, say, wetlands, where you have to look at, both surface flow and groundwater flow and the exchange between the two. And Ecolab then can add on top of that any processes that you want to describe that involve that those interacting water bodies. Mike Shee can be run on a short time scale and a long time scale, so you can actually look at event-based situations, or you can look at multi-year, 40, 50, 100-year scenarios. And within Mike Shee, you can actually define time-varying land use profiles. So if, when you're looking at 10 plus years, the change in the land use, the vegetation cover, for example, the types of vegetation that are occurring within the watershed area is critical to getting the water balances correct. And that can all be represented in Mike Shee. Just moving down the right-hand side of the circle there, we've got Mike Hydro and Mike Hydro River. So these are our two water resource workhorse software. So Mike Hydro Basin is kind of a mass balance model that moves water around, and it's very powerful tool if you're looking at optimization of river systems, for example, with reservoirs and hydropower dams, and you want to look at conjunctive use of the water resource system, then it has a very powerful optimization and multi-objective optimization capability. So you can really look at configuring the system so that you're meeting those competing objectives. Mike Hydro River is a one-dimensional St. Venant equation flow solver. And again, same as the marine software, you can add on layers, transport processes, water quality, morphology on top of the basic hydrodynamics. And Mike Hydro River is the software engine that's used within Mike Shee for the water channel simulation. I'm just going to jump across to Mike Urban Plus and West. So Mike Urban Plus is our new version of Mike Urban. Mike Urban is our urban drainage modeling software. And Mike Urban Plus is the next generation. So it's basically a new user interface platform for Mike Urban. And with Mike Urban, you can simulate the water supply systems, wastewater and stormwater collection systems in one modeling platform. And again, you can simulate the hydrodynamics and then add on all the complexity. The link I can provide you for this is to our software catalog. I'll actually just, if you just bear with me a second, I'll just paste that into the chat window for you, so that if you did forget to send me an email, then you can at least see the full spectrum of the software. And that's there's a lot of detail in there around what each software can do. And so just moving across to West. West is our wastewater treatment plant process simulation software. And West and Mike Urban can be coupled together so that you can simulate the dry weather and wet weather inflows into your treatment plant using Mike Urban Plus over a long period of time or event-based. And then within West, you can look at the process performance of the plant and carry out optimization if necessary of the treatment processes to maximize the efficiency of the treatment plant, all the time looking upstream at what may be coming in from the network. And then I just want to circle back onto Mike Flood. So Mike Flood is actually our coupling interface. A lot of these software products can be coupled either within an interface or within an ASCII coupling file. But MyFlood is our GUI, user interface, for coupling together the Mike21 2D modeling with the Mike Hydro River 1D river channel modeling and the Mike Urban Plus pipe modeling. And MyFlood allows you to define the hydraulic couplings. So for example, from your stormwater inlet on the catchment surface to the pipe system below, and along the river banks of a river channel to the floodplain. So you can define how the flow is exchanged dynamically, and MyFlood will simulate both the two-dimensional overland flow, the one-dimensional river channel flow, and the 1D pipe flow. And it's not just a hydrodynamic coupler, you can actually dynamically couple advection dispersion in MyFlood as well. So if you're looking at salt concentration, say, from a storm surge event on the coast, and you want to see how far that might propagate up a river channel and spill into an urban system and backflow up the urban pipework, then the concentration can be also transferred through the couplings. So it's a pretty powerful platform. Also within MyFlood, the two-dimensional overland flow solver can be coupled with the fee flow groundwater model. So if you have surface water or floodplain groundwater interaction, you can capture that as well. And then the other item in the middle there next to Ecolab is SDK. I've got some more details on that. I'll circle back to that. That's our software development kit. So I'll pick up an explanation of that shortly. So that gives you an overview of our simulation software that's available. And then just let me move forward, sorry. Then we have our Mike operations software. As I mentioned, this is our commercialized decision support platform. And so Mike operations is a platform. It's a little hard to see, but down the bottom there's some screenshots of the system. And it basically has a whole load of components. You can see there we've got models, scenarios, time series, etc., etc. And what this Mike operations allows you to do, it's essentially a database that you can bring spatial and temporal data into, and you can also hook up to sensors and other databases online and schedule data retrieval from those sensors or databases and bring that into the Mike operations database. You can then make maps and time series plots and dashboards displaying that information. You can then import the Mike models into Mike operations and automate the picking up of that data and using it for boundary conditions and initial conditions for those models. And then you can schedule simulations at certain points in time of those models and automate that as a job process. And then you can have custom reports that present both the data and the model results in various views. Within there's also components to carry out multi-criteria analysis and cost-benefit analysis using some internal optimization routines. And again, those optimizations can be scheduled. They can be carried out as a one-off or scheduled. And for a lot of the data analysis and manipulation, there's pre-configured tools that you can stitch together in a workflow and a job process. So you can really build or represent your workflow that you may be carrying out, making forecasts or even just running models and reporting on the results. And you can capture that workflow as a series of tasks and automate that as a scheduled job to run at a certain point in time repeatedly. So it really, I see this as really bringing the model to life. It's that third layer that we talked about in the system, where you've invested a lot of time and money and resources in establishing these simulation models. So you can really bring it to life here. And the views that I mentioned from Mic Operations, you can build up configurable products. So these are desktop applications that you, as the configurer using Mic Operations, can define the look and feel of what the desktop user would see. And it's highly configurable. And so people would have a login, and typically it's internal people within an organization, so system operators and planners. And you can actually create user interfaces so that people can input information and for example, maybe run a model scenario, what if scenario, what if this parameter was changed, or what if we have a blockage at a certain location in an urban infrastructure system, what's the effect? And so the user doesn't necessarily need to dig into the model. They can access or provide input to the models at this desktop level. And then you can go one step further. You can publish the desktop application as a web page so that you can expose that information and allow input from a greater audience, such as managers, decision makers, and the public. And you can also, the system has a web API. So if you have your own web solution, then you can hook up to Mic Operations through an API and exchange information with your own web solution. Super powerful. I'd encourage you, if you're in this space, to definitely get in touch and talk to us about this, how this might be able to help you. I just want to touch on the documentation that you get with the Mic software. It really is quite comprehensive. So with each software product, you get a whole series of manuals. This is I'm using the Mic 21 two-dimensional flow model here just to illustrate what you get. But basically, you can see there's the hydrodynamic module, as I was saying, different layers, transport module, ecolab, oil spill, mud transport, etc., etc. And within there's typically a user guide and some scientific documentation, and then a step-by-step training guide that basically takes you through using the software from start to finish, and a sample data set is provided with the installation so that you can go through that step-by-step training guide and get some appreciation. So if you have domain knowledge, you can quickly get going with the Mic software. There are, as I mentioned, within the download, then there's on the right-hand side, you'll see there Mic 21 examples. There's a whole series of examples illustrating different aspects of the software, and they're documented in the user guide. So they're pre-made setups that you can look and modify and test out your ideas with. This is actually really cool if you're even working on projects, your own projects, but you want to test out a particular schematization. In most cases, you can pick up one of those examples that's kind of close to what you've got and just tinker with it to test out your ideas before implementing in your project model. So I'm calling this little section here free viewers, because a lot of people are not aware that if you go to the Mic download page and download our software, you can install the software without purchasing a license in most cases, and you can actually open the software and use it in demo mode. And the demo mode basically is a restriction on the ability to save edits to the input files and output files. And you can run simulations with a limited size model. So it is quite restrictive, but you can definitely run some of the examples that come with the downloads. But the viewers, so the interface, the GUI, and the ability to view an input file to a simulation engine and view results files is fully functional. It's not size restricted. You just can't save edits, of course. So if you have customers that you're trying to pass results to, they can actually view those results or input files with the viewers free of charge just by downloading the software. A lot of people think they actually need the full license to use these viewers. Some of the software, like FeeFlow, actually has a dedicated viewer that's sort of separate to the actual software. So if you're in that situation, I'd encourage you to check out that, download the software, have a look, check it out. And I just want to touch next on APIs to the Mike world. So this is really quite an exciting development that we've formalized in the last couple of years. So for those of you that don't know, the Mike simulation engines are, of course, proprietary engines. So they're executable files. And typically they're reading ASCII format input files, parameter files. And for boundary conditions for time series, they're binary format files. And the outputs that are produced from the simulation engines are typically binary output files. And what we have done is published, we call it the Mike SDK, and we have published the API for all of the Mike data file formats, both input and output. So if you download the Mike SDK, that basically has some documentation that allows you to, in your scripts or your code, to build and read and write to all the Mike input-output files. So if you have a particular workflow or process that you use to create model data, model input data, then you can actually automate the building or population of Mike input files within your Python scripting or your coding. It's huge in terms of giving you flexibility to set up your Mike models and to work with the results. We have a number of APIs. So the first API that I mentioned there is really for the input and output of Mike data files. The second API is for the Mike operations platform that we just talked about, where you can operationalize your model. You can hook up your data to your data sensors or your real-time databases. You can bring that information and the model results alive with dashboards. Each of those components has an API, so you can actually integrate your tools and your code within the Mike operations. So again, it just makes it infinitely extensible. And then we have a number and a growing list of APIs for our simulation engines. And this is super exciting. Excuse me. So the engines that I've listed there are FeeFlow, which is the groundwater simulation software. WEST, the wastewater treatment plant simulation software. Mike 1D, which is the computational engine in our 1D river channel. So that's Mike Hydro River software. And our urban pipe flow modeling, that's Mike Urban Plus software. That's the computational engine. And Mike Shi, which was the fully integrated hydrological simulation software. So all of those engines, we have an API. The Mike Shi is brand new. It's just out in update number 1. And that is a Python interface within the Mike Shi GUI that allows you to access certain computational parameters at runtime. It's fully documented in the user manual that comes with the update number 1. So if you're a Mike user, I definitely recommend checking that out. That could certainly open up some doors. Mike 1D is a documented API for the engine. So it allows you to basically interact with the computational engine during the simulation. So for example, if you have a river channel with a stop bank level and you want to stochastically fail a particular stop bank length with a failure profile at some time during a long-term simulation, then you could write some Python script that would carry out or describe that failure process, and actually at runtime update the parameters in the Mike 1D simulation to reflect a change in stop bank. That's just an example. West has a full interface for the computational engine within its own GUI, and the same for FeeFlow. FeeFlow has a Python interface for the engine. So a lot of people don't know about these APIs. In terms of licensing, if you're working on a project, then the input-output APIs are freely available to be used. But if you're building a product or a service that's using the Mike engines or the Mike data file formats, and you're providing that to third parties, then we have an OEM partner program that you can join and negotiate with DHI and a license agreement whereby you can use these APIs within your system and access, for example, the Mike computational engines as part of your solution that you're delivering. So super exciting, and if that's of interest, definitely check out our website. There's some information on the OEM partner program, or get in touch with myself. So I just want to circle on to the Mike licensing. We've recently in January this year, revised our licensing types. So I'll just run through those super quick. We have a subscription license, which is pre-defined bundles of software with a little bit of flexibility on some of the modules you can choose in the marine software. But essentially, there's a groundwater subscription package, a hydrology and hydraulics package, an urban package, a flooding package, and a number of marine packages. They're available to be, you can have a subscription for 12 months, or you can take monthly subscriptions. There's a minimum of a 2-month initial subscription, and there's a little premium on the subscription if you want it at a monthly timescale. You get a number of bonus modules with the subscription, such as the Mike Animator, which is a results visualizer, and certain compute capabilities of the software are unrestricted in the subscription license. We then have 2 perpetual licenses, which are professional and essentials. And the professional license, basically you can choose exactly which modules you want from the full range of available modules. So you can pick and choose and build your own license. And there's some dependencies, of course, on certain modules. For the advection dispersion, the prerequisite is that you have the hydrodynamics. Those licenses are delivered as network licenses or internet licenses. So an internet license basically means you install the software on a piece of hardware and you point to a DHI license server, and then you're good to go. A network license is where you would install a dongle on a network server somewhere in your organization, and then you would point to that network server. You get, as I say, the full range of modules are available, and if you have an active support and maintenance agreement, that's the SMA bit here, support and maintenance agreement. If you have an active support agreement, then you get access to these bonus modules and the unrestricted compute capabilities, such as unlimited CPU cores for the simulations, and unlimited GPU cards for the simulations. If you're out of SMA with the professional license, then you get 16 core limitation CPU core and 8 GPU core limitation per simulation. And each license, each seat, comes with the ability to do 4 concurrent simulations. That's the same for the subscription license. The subscription license, I'll circle back to that in a second, is available in multiple user blocks. So you can have a 1 user license, 2, a 5, 10, and I think a 20. It's detailed on the website. But the really exciting thing about the subscription license is if you take a 2 user subscription, then you actually get unlimited simulations of the engines within that subscription bundle. So if you take a 1 user license, you get 4 concurrent simulations. But if you take a 2 or more user subscription, then you actually have unlimited simulations. And then couple that with the internet license, which means you can actually utilize cloud hardware to have many, many instances of mic running. And so you can really start to tackle peaks in your simulation workload, or start to look at uncertainty analysis, sensitivity analysis of the models. It really opens up a whole new world. And then just to mention the essentials license. So what we've done is we've put some restrictions on the professional license, and the 2 main ones are on the modules. So certain modules you can't purchase under an essentials license. And there is a restriction on the compute capability. So the essentials license offers 1 simulation per seat and has a maximum of 8 CPU cores and no GPU. You can purchase a GPU, 1 GPU card capability on top of the essentials license if you desire. But the upshot is that the essentials is more affordable if you're that way inclined. Over on the final license type is an academic and student license. Again, a lot of people are unaware of this license type. So if you are engaged in non-commercial research at a research institute or a university, then there is a discount on the professional license price. And if you're a student or you have students working for you doing a thesis, MSc or PhD theses, then they can actually get access to a full license at no cost on an annual basis to use the software on their thesis research. And I mentioned the internet license being available on the subscription and the professional license. And just recently, we've released mic software to be available on the Microsoft Azure Marketplace. So I'm assuming everybody's sort of aware of Microsoft Azure Marketplace, but if not, check it out. If you just go to our website, there's a link that takes you directly there. And there's a nice guide there, how to get going. But basically, here's a screenshot from Microsoft Azure Marketplace for Mike. And what it means is that you can purchase per hour cloud hardware on the Microsoft Azure platform that comes with Mike pre-installed. And it's kind of a BYO for your license. They actually call it, I forget what they call it. Here we go. BYO, bring your own license. So you need a mic license, and this is where the internet license really comes into its own. Even if you have a 1 user or a 1 seat license, that gives you 4 concurrent simulations. So if you don't have 4 high-spec computers available, you can come to the Azure Marketplace and purchase that hardware and have it preloaded with mic and be up and running, point to your internet license, and away you go. If you have a 2-user subscription or more, then the sky is the limit. You can actually purchase 10, 100 or more computer instances and with mic preloaded, and carry out, a phenomenal number of simulations in parallel. So if you have a deadline to meet or a sudden unforeseen increase in simulation demand, this could be a really good way to go. And I won't get into the pricing and stuff, but this is just to give you a flavor for the plans and pricing that's available. These are 3 instances that we've recommended, but you can choose from any instance that's available on the Azure platform. And you can even scale the machine up once you have the instance running. So you can take a particular instance, and then if you feel you need to increase this number of cores, for example, you can do that on the fly in your Azure account. So you can see the infrastructure cost there. This is in US dollars per hour, and it ranges from just under $1 to $7 for a compute optimized 64-core machine. But you can imagine if you have a high-spec machine and you can get through your simulations in a few hours, that could be a very feasible way to go. That's super exciting, new off the hot off the press, the Azure marketplace. It doesn't mean you can't use the mic on any other cloud platform, of course. You just have to manually install the software and point to your internet license. Just finish up on the support and maintenance agreement here. When you buy the software, you get the first year of support and maintenance is included, which is great. It's included with the subscription offerings as well. In a nutshell, you get access to our technical support hotline via email or telephone. And, as I mentioned earlier, we have the people conducting support, our technically qualified people, so they speak your language and can help you out. You get software updates. So as I mentioned, update number 1 is out right now with some really cool new features in there, new capabilities. And so you would get, if you're in SMA, you get full access to those updates. And you get some preferential rates on training courses that we run for the software. We also offer extended support agreements if you need something beyond the standard software support. I won't go into details on this, but get in touch with us if there's stuff beyond the standard software support that you may be interested in, and you can get access to DHI expertise at quite preferential rates. If you're interested in training for the mic software, then check out the Academy by DHI. That's our website that details all the training that we run. Huge selection of training in different languages around the world, at different time zones, and some self-paced courses and instructor-led courses online and physical courses. Huge selection, so definitely check that out. And I'll just finish with a look to the future. If you search for DHI annual report 2018, there's some really nice words from our CEO explaining where we're going with our CloudBridge strategy and what that means for you as mic customers and even competitors. Explains what it means. It's a very exciting time coming up, so I'd encourage you to take a read. If you do a search, DHI annual report, I can send you the link. There's some really cool illustrations of what we're doing and where we're going on this. The key message is that we're with the cloud and with our technology in the cloud, it really opens up the opportunities to co-create technology solutions with you guys out there. It's exciting times ahead. And on that note, Barbara, I haven't left you much time for questions, but I didn't see too many popping up, so I hand back to you, Barbara.
Okay, thank you, Colin. So we open up to questions. If anybody has any questions, please feel free to send them through on the chat and we'll be happy to answer them. So we'll just give it a minute, see if anybody has anything.
Sure. As I mentioned, if you're interested in getting the links to things, pretty much everything I talked about, I've got links for. If you email mike@dhigroup.com, I've just put it in there. And if you mention this webinar, then I'll make sure that you get the links.
Okay, Colin, so we have a question here from Fernaz.
Okay, hi. Okay, I want to model surface and subsurface water. Okay, is that so? What situation is it better to couple My21 and FeeFlow? Okay, it really depends, as always, on what you're trying to predict or what you're trying to simulate. If you're looking at a very complicated groundwater situation, then FeeFlow would definitely be the tool to describe that. And yes, you could then couple that with Mike21 to simulate the surface flow. If you're looking at event-based or relatively short timescale phenomenon, then FeeFlow and MikeShe coupled together could be the way to go. If you're looking at a more holistic surface water groundwater interaction, such as a wetland, or I don't know the specifics of your problem, and you have, you want to describe the phenomenon that's occurring with land use change, you want to look at the unsaturated zone in particularly, then the MikeShe software could be the way to go, especially if you're looking at a more long time series analysis. But if you want to catch up outside of this webinar, feel free to drop me your details on an email, cjr@dhigroup.com. I'm just typing that in here for you, and I'd be happy to hook up and discuss your case.
Okay, so we have another question from Simon.
Okay, hi Simon. Have you done much performance testing on cloud platform versus local hardware to understand what equates to good performance for large models? We have a PDF on the website that talks about GPU cards and different cards and the performance improvements that you get with those. We, as far as I'm aware, we haven't published too much on the different cloud instances that you can get and the performance improvements. So, I mean, the rule of thumb that we have with the engines that are able to utilize multi-CPU core is that there's almost a one-to-one speed increase with the engine performance based on the number of cores that you're providing. But we haven't actually published this particular cloud instance gives you this performance over a desktop. But if you're particularly interested, as gave you my email there, drop me an email and I could connect you with somebody who's carried out that evaluation, and I'm sure they'd be happy to talk to you about that. Okay, we got another question there. Have we got any more questions?
Nope, I think that's it.
Okay, cool. So yeah, if you Fanaz and Simon, feel free to drop an email to me, and I can talk to you or connect you with somebody who could take a deeper dive on that one.
Okay, well, great. Well, thank you, Colin. I think that's a wrap for today, and thank you everybody for attending. And if there's any questions, please feel free to either contact myself or Colin.
Yeah, thank you very much for your time, and have a great day, whatever time it is for you guys.
All right. Okay. Thanks, everybody.